Okay, so we continue to work on NumPy. Yesterday we created um, our first NumPy object. Okay. Now let's create one more. Okay, so this is called mat1. Let me create one more. We call this as list2, and let's have some different set of values. 2, 3, 4. Okay, 2, 1, 2. We'll make this as 5. 2. We'll make some changes. Okay, we call this as mat2 list2. Okay, let's print it. Okay, we just created, oops, it's working on
Of
wrong
course.
file. Okay, so we have so this is how many rows? What is the size of this?
4 into
4 into
4
3.
rows, 3. Mhm.
Correct. So we have 4 rows into 3. That's the size of the
Matrix.
matrix, or we call it as shape. Okay, this is also 4 into 3.
3.
Now you can add. Okay, so
Matrix.
matrices operations. Okay, so we can add them. So how do you add? You say print, okay, mat1 plus mat2. Okay, or you can also say numpy dot add. Numpy dot add mat1 comma mat2. Mat1 comma mat2.
Matrix.
Now when you see, okay, so this is your first matrix, this is second matrix, right? So you have 1 plus 2, 3, 5 plus 3, 8, 7 plus 4, 11, right? So see, this has created a sum of this. So, okay, elements are added based on the index. So 0, 0 of both the matrices will be added together. 0,
Yes.
1 plus 0, 1, 1, 0 plus 1, 0, right?
Yes.
Those will be added together and you get, okay,
Addition.
addition of matrix. Okay. Now, similarly, you can do subtraction, multiplication, right? So let's say I go back here and let's say we want to perform minus. So you can say mat1 minus mat2 or np dot subtract. Okay. Similarly, you have multiplication and division. Okay. You can multiply them. Okay. So we'll say multiply. Okay. You can divide them. Say divide. Okay. You can multiply, you can divide. Okay. And it works just like that. Okay. But I told you yesterday to read matrices properties. Okay. The multiplication, what we have done is called element multiplication. It is not matrix multiplication.
Yes.
Okay.
Yes.
Matrix multiplication is different. Okay. Matrix multiplication, first of all, okay. If I go to paint, so if I have to do matrix multiplication, right? So if you have, this is mat1, and if you want to multiply with mat2, actual matrix multiplication order is important. Okay, you know m1 into m2 is not same as m2 into m1 in matrices. Okay, m1 into m2 is not same as m2 into m1. So order is important. First point. Second point, for it to happen, okay, if the shape of m1 is m into n, let's say, and M2 is say x into y, small x into small y. So what happens is first condition is that this n should be equal to x. If n and x are different, then you cannot perform matrix multiplication. If n and x, that means number of columns that first matrix or left side matrix has. Number of columns this has to be same with number of rows this has. Okay, that's why
Yes.
order is important here. So number of columns of left side matrix should be same as number of rows in second left right side matrix. Otherwise, you cannot perform matrix multiplication. Okay, and the resultant matrix, okay, is of size m and y. Okay, so it takes number of rows from left side and number of columns from right side, and I'll show you how actual multiplication is done. But this is the first condition. Okay, now in our case we have 4 into 3, right? And then you have 3 into 4. Sorry, 4 into 3 only. Both are 4 into 3. Now this 3 and 4 are not same,
Yes.
correct?
Yes.
So the matrices we have, we cannot perform matrix multiplication. Okay, let's try to do that first, and then we'll see how it is done actually. So if I try to multiply mat1 and mat2, so to perform matrix multiplication, we have a function called matmul. Okay, actual matrix multiplication is done using matmul. Okay, so here if I try to say np dot matmul, okay, mat1 comma mat2. If I say mat1 comma mat2, okay, it will give you error. Okay, operand 1 has a mismatch in score dimension. Okay, so it says nkm, n into k and k into m. Okay, this k is not same. Okay, so n into k into m should give us n into m. Okay, and this k, obviously they are not same. That's why you get an error. Okay, the actual matrix multiplication is done this way. Let me show you an example. Okay, you see this is how matrix multiplication is done. So if you have this is your left side matrix and this is your right side matrix. Size of this matrix is 2 rows 3 column 2 into 3, and this is 3 column 2 rows 3 into 2, right? 2 into 3 3 into 2. So number of columns left side is same as number of rows on the right side. So matrix multiplication is possible here. Point 1. Point 2, the resultant is going to be number of rows from here. So 2 rows, and number of columns from here, 2 columns. So 2 into 2. So this is the output matrix. And the process that is done is, if you're talking about, okay, so the output will have 2 rows, 2 column. If you're talking about the matrix, the value that will come at 0, 0. Okay, so for 0, 0, you have to multiply 0 rows of left side into some, it's called product sum. Okay, product sum of first row and first column. The output that we want for first row and first column is product sum of first row from left side and first column from right side. So it is 1 into 10 plus 2 into 20 plus 3 into 30. So 10 plus 40 plus 90. Okay, 140. Now this is your first row, second column. First row, second column. So some product sum of first row into second column. So it's going to be 1 into 11 plus 2 into 41 plus 3 into 31. 33 plus 42 plus 11. Right? So one here, 2 here, and 3 here. So 6 more than left side, 146. This is your second row, first column, right? So product sum of second row, which is 4, 5, 6, into first column, which is 10, 20, 30. So 40 plus 100 plus 180. 180 plus 40, 220 plus 100, 320. This is second row, second column. Second row, second column. So second row of first matrix into product sum of second column of second matrix. So it is 4 into 11, 5 into 21, 6 into 31, which is 335. So this is how matrix multiplication is done. Okay. So that's what I told you. Here, the column of A should be same as rows of B. Okay. So let's go back to our program. So obviously, we cannot do Mat 1 and Mat 2. Okay. What we'll do is we'll create Mat 3. Okay. We'll create Mat 3 here. I'll call it as 3. We'll change the value later. Mat 3, L3, Mat 3. We will say Mat 3 here. Okay. Now see, Mat 1 has 4 rows and 3 columns. Correct? 4 rows and 3 columns. Our this one should have three rows only. It cannot have more than 3 rows. Okay. So I need to delete one. Okay. Now the column doesn't matter, right? Column doesn't matter. So what will be the output of this L1, M1 into M3? 4 into 3, comma 3 into 3. So output will be 4 into 3 itself. 4 rows and 3 column. So when you run it, you get 4 rows and 3 columns. Now see, matrix multiplication is possible now. Okay. So this is how you perform matrix multiplication. Okay. Matrix multiplication. Okay. So you have M1, M3. You can also do, okay, using operator called as at the rate. M1, okay, at the rate M2 will give us matrix multiplication. Okay. You get same value here. Okay. This is how matrix multiplication is created. Okay. Okay. Now, um, what we'll do, as promised yesterday, we will use this to solve a linear algebra problem. Okay. We'll use this to solve linear algebra problem. So, okay, let's take a linear algebra problem. Okay, let me again go to Google, and what we'll do is we'll type here linear algebra problem. Okay, let's take any one problem. Is it clear here? Let's see. They all talk about matrices only because that's the easiest way to solve. I'm looking for problem, some problem statement. Hmm. See, everybody is solving using matrix. I'm looking for a statement which will convert into matrix. Nobody's talking about that. Linear algebra problems. Let's look for PDF. Maybe that will help. Is this the one? Okay, let's try to solve this one. Let's see if we can. Okay. Okay. So let's take this one.
Yes.
Here
Yes,
you
yes.
have x1 plus 5x2 equal to 7. So let me write it down. Linear algebra equal. So x1 plus x1 plus 5x2. 5x2 equal to 7. Okay. And you have minus 2x1 minus 2x1 minus 7x2 x2 equal to minus 5 equal to minus 5. Okay. Right. So this is the equation that we will solve. So coming back to our pie chart. Okay. So before we solve this, do you know what is determinant? What is determinant of a matrix?
Mm.
So in a way, okay, determinant, okay, is a um, is a single value, okay, which can represent the matrix. Okay. So the formula to calculate determinant is different based on, okay, based on the size of the matrix. Okay. So for 2 by 2 it is different. 1 by 1 it's easy, the number itself. 2 by 2 it is different. 3 by 3 it is different. Okay. So determinant of a matrix is a single numerical value which is used when calculating the inverse or when solving systems of linear equation. So determinant is like a single value which can represent, it's like representing the entire matrix. Okay. Okay. So for example, okay, for 3 by 3 matrix, if you see, this is how you calculate. So you fix, okay, AI, and when you fix AI, that entire row and column is ignored. Okay. Then you multiply main diagonal B2 to C2 and subtract B2
Yes, yes.
C3.
Yes, yes, yes.
Okay. So
Yes.
again, if I take you to paint and we'll try to do.
Got it.
Okay. So let's say you have here value like 1, 3, 5, 1, 1, 1, 2, 3, 4. Okay. So first what we are doing, you have to take first value.
Yes.
Okay. And then if you take this first value, this entire row and column is kind of hidden.
Yes.
So it will be 1 into element on main diagonal. So these are hidden. So you have 1 into 4, 4, and then
Minus one.
minus 1 into 3. Okay.
Yes.
Then, okay, I'm not putting any sign. I'll tell you why. I'll put it later. Now, second
Three.
value, right? So now this time I have to take this one as constant. Okay. So this is gone. So it is 3 into, now the element on main diagonal is 1 into 4. So 4 minus 1 into 2, 2. Now the third, so 5, okay, and that first row and uh, third column, okay, is hidden. So now you get 1 into 3. 1 into 3 is 3, minus 2 into 1 is 2.
Two.
Okay, So this is how you create. And then what you do is you put plus sign here, alternate plus minus plus. If you had one more, it would have been minus. So it is plus. So it is 4 minus 3 is 1 into 1 is 1 minus 4 minus 2 is 2. 2 into 3 is
6
6. So minus 6 plus
plus 5.
3 into 2, 1 plus, yeah, 1 into 5 is 5. Okay. So what's the value? What is determinant?
0.
0.
Yes.
Determinant is 0. So, okay. So number 0 is used to represent this entire matrix. If you have to use one single number, to represent the matrix, it is 0 here. Now, if the number is 0, you cannot divide, you can't perform inverse. Inverse is 1 by of a matrix.
Yes.
Okay. You can't perform inverse of a matrix if determinant is 0. Okay. And we have formula to calculate inverse directly. Okay, I told you you can you can refer the meaning of inverse and dot matrix, okay, in mathematics. We'll come back to our program and we'll take the same value 135, 111 and 234 and we'll try to create determinant and we'll see if inverse is possible or not. So I'm going back to our program. Okay. So what was the, okay, so I'm saying here calculating determinant. Okay. Now you have matrix L4 equal to, it had 3 rows and 3 columns, right? So, okay. So values were 135, 111. 135, 111, and then 234. 234. Okay. Now, if I have to convert it to matrix, I'm going to say mat5 equal to np dot array L4, right? This is your mat5. Now, how do you calculate a determinant? Okay. To calculate determinant, we have to use what is called as linear algebra. Linear algebra class of your Numpy. So it has a class called linear algebra. Okay. I need to switch on the power. Just give me a second. Okay. So, okay, mat5 is ready. Now we have to use linear algebra class. So how do I do that? So I'm going to say determinant of mat5, something like that. Determinant of mat5 equal to np dot lin algebra dot determinant. You see, there's a function called determinant here. So determinant of mat5. Okay, print here determinant of matrix 5 is det mat5. Okay, and you run it, you see it is 0. You just calculated 0, right? Determinant is 0.
Yes.
So you can't perform inverse, you can't do inverse of math. So what I'll do, let me change the value here and see if there is any impact. So now determinant is minus 12, right? We can perform inverse. So if you want to find inverse of matrix 5, you say print inverse of matrix 5 is np.linalgebra.inv inverse of mat5. Okay. Now mat inverse of, okay, 1 by 0 is not defined, isn't it?
Mm.
Okay. You can't calculate. So you see
Okay.
here, this is the inverse. Okay. You can put /n so that it comes in the next row. Okay. So this is your inverse of matrix. Okay. Now tell me, what is the answer of 1 by 0? Is it infinity or error or not defined? What do you think? What is the answer of 1 by 0?
Infinite.
Okay. Okay. Let's discuss about 1 by 0, okay, for a second. I'm taking you to paint again. So see, okay, 1 by 0.001. How much it would be? 1 by 0.001.
Yeah.
Hmm?
Mm, 1 point.
What? All of your engineers, what is this?
8,000.
1000, right?
Yes.
Yes. It is 1000, right? So, okay. Now, so you say 1000. Now, if I keep on adding 0, 0, 0, 0, 0, 0, 0, 0, 0, you know, what will happen
Mm.
to the value?
It will increase by another
It will be
0.
increasing, right? Okay, it's going to be very big number, right? Okay, so what happens when you have 0.000000001? It tends to go to infinity. Okay, so 1 by very small value, very, very, very small value tends to go to infinity. Okay, so if you draw axis, it will go somewhere like this. Okay, as the value x increases, tends to 0, you know the result will go up, right? It's like, that's why I say it is infinity. Now I do same thing, 0.0000, very small value, and I put minus. Then what will happen?
It just become smaller, 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 smaller.
Smaller? No.
Right.
This will become smaller. What is the total answer? 1 by very small value minus 1 by
Minus
very
infinity,
small.
like minus infinity or something.
It will go to minus infinity. Okay, so if you draw xy axis, you get something like this. Okay, so this is 0, right? This is minus infinity somewhere here, right? This line is going to meet this line at minus infinity. So if I have plus 0 point very small value, it is plus infinity. And if you have 1 by very small value minus, it's going to be minus infinity. Okay. Now there's a difference between very small value and 0. Okay. Now 0 is neither positive nor negative. Correct? Now 0 will not be here also, will not be here also. Will it be here? 1 by 0, is it 0? No.
No.
So that's why, will it be plus infinity or minus infinity? Okay. That's why we say 1 by 0 is error. 1 by 0 cannot be calculated. It is error. 1 by 0 is not infinity. Okay.
Okay.
1 by 0 is error. 1 by very, very, very small value is plus infinity. 1 by negative, very, very, very small value is minus infinity. But 0 is neither plus infinity nor minus infinity. Okay. So 1 by 0 is error. You cannot calculate. That's why if you use any of this programming, or even if you can take it in calculator also, if you say 1 by, okay, 1 by 0, it will give you error. It will not say infinity or very high value. Okay, because 1 by 0 is error. You cannot calculate 1 by 0. Okay. So it should move between plus and minus infinity, correct? If it is moving between minus infinity plus it's, then what's the meaning of there's no meaning at all, isn't it? And there's no sense of saying 1 by plus 0, 1 by minus 0. 0 is 0. 0 cannot be negative value or positive value. If it is for very small positive value, it goes to plus infinity. If it is very small negative value, it goes to minus infinity, right? 0 cannot go anywhere, right? So 1 by 0 is neither plus infinity nor minus infinity. It is error, okay? So that's why we cannot do any work when you have, I mean, at least you cannot do division if it is 0 in the denominator. Okay. So now coming back to our discussion here. So if you have a 0 here, you can't find inverse. Otherwise, you can find inverse. Great. Now let's come. Why are we talking about determinant and inverse? Let's try to solve this equation here. Now, how do we solve this equation is, okay, we'll divide this linear algebra into 3 matrices. Okay. First matrix is your constant. Okay. So we have 3 matrices here. Okay. So we have constant metric. Okay. Constant matrix is going to be, or instead of constant, let's call it coefficient. Okay. That will be, that makes better. Coefficient matrix. Okay. So we look at the coefficient of these values. So we say NP dot array, and then we create this list here. So it has 2 rows and 2 columns, right? 2 rows and 2 columns. Coefficient 1 plus 1 plus 5 minus 2 minus 7. So you have 2 rows. And first row has value 1 comma 5. Correct? And second has value minus 2 comma minus 7. So this is your first row. This is your second row. Okay? Coefficient matrix. Next, we create what is called as your variable matrix. Okay, so variable matrix is going to be x1 and x2, right? So this is like, okay, we can't execute it. You know, it needs a value. It needs a variable, right? So here, okay, you have x1 in the first row and x2 in the second row. Okay, so you will say x1 and you will say x2. Okay, this is how this real matrix will look like. But since we don't know the x1, x2 value, this cannot be converted into matrix. Okay, so we will comment it out for now. So this is your variable matrix, and then you have your output matrix, the answer or result matrix. Okay, so result matrix is again numpy dot array, and okay, so you have, okay, so you have 7 and minus 5. Okay, so this is your result matrix. So coefficient matrix into variable matrix equal to result matrix. Okay, so the equation here is coefficient matrix into coefficient into variable, right? It's like 5x equal to 10, right? That's how the equation we are. So the matrix form we have converted into linear equation, which is 5x into 10. 5 is your coefficient matrix, x is your variable matrix, and this is your 10 is your resultant matrix. Now something like that, right? Generally, that's how we write, right? Example, okay? Example is like 5 into x equal to 10, no? Something like that. Now, if I need to find x, what do? We take 5 on the other side, okay? Which is variable. This is what we need to figure out, right? Variable matrix need to figure out. So variable matrix is, okay, 5 goes on the other side. So 5 becomes inverse, right? So this is going to be coefficient matrix inverse into your result matrix. So if I find inverse of coefficient matrix and then do matrix multiplication with result, I'm going to get my variable matrix. Okay, that's how it is. So how to get inverse? So before calculating inverse, we have to check if this value is not 0. If I say 0x equal to 10, then obviously you can't find the answer, right? So here you have to check the determinant value. Determinant of coef matrix equal to np dot not BP, NP dot lean algebra dot determinant of which matrix? Coefficient matrix.
Coefficient.
Okay. Now this debt coefficient matrix, okay, is not equal to 0. Then I'm going to say pass. We'll come back and calculate. Else we'll say solution is not possible for these values. Okay, or let it be solution is not possible. Now when I talk about coefficient determinant, okay, so now if determinant is done, then what we do? Then the answer, okay, or result or your variable matrix, right? Variable matrix is going to be NP dot lean algebra dot inverse of your coefficient matrix. Okay, at the rate matrix multiplication at the rate your result matrix. Okay, and this you can print it. Okay, so if you want x1 is equal to, okay, so this is a matrix of 2 rows and 1 column, variable matrix. The first value is x1. So how do you define first value? 0, 0, right? First row, first column. And your x2 equal to variable matrix of, okay, row will change, 1 comma, column is same. So when you run it, you see it is -8 and 3. Okay, -8 and 3. You can put it in the equation and see the value. Okay, so we are saying x1 is -8 and x2 is 3. Okay, so x1 -8 plus 5 into 3, 15. -8 plus 15, 7, correct? And minus 2x1, that means minus into minus is plus. So this will be 16. 16 minus 5 into 3, 21. 16 minus 21.
-5.
Yeah, -5. You see, it is meeting our requirement. And let it be any power, right? It can be 3 by 3 matrix, 4 by 4, 5 by 5. Okay, you can solve using Numpy. This is one application of Numpy in our data structure in Python. Okay, makes sense?
Mm.
Okay. Okay, with that, we finish our Numpy topic. Okay, I'll just introduce something called as Scipy. Scipy. Again, you have to do pip install to access it. Scipy actually is a short form for Scientific Python. Scientific Python. Okay, all the scientific kind of examples. Okay, you talk about, in physics would have done 4 years theorem. Okay, in mathematics we have done permutation, combination, trigonometry. Everything can be done using scientific Python. So scientific Scipy has classes like um, you know um, uh, IO, okay, to read, let's say, a matrix. If you have a matrix and a text file, you want to load it, you can use IO, you can use stats, okay, to perform statistical optimization. You also have linear algebra problems. Now, what we just did is called equality problems. Okay, what we just did is equality problem. You can have inequality problem also. you can have inequality problem also. Inequality problem means generally when we talk about optimization or operation research in mathematics, okay, we have inequality problem. Inequality problem means the values are either greater or less. Okay. Now let's say you want to start a company. Okay. And let's say you want to start a computer parts assembly company. Okay. So you start a company, computer parts assembly. Okay. And let's say you have two products, okay, that you make. You make laptops and desktops, let's say. So you make laptops and desktops, right? Now, laptops and desktops, okay, you make. And what is the objective of any business? Okay, so objective of any business is to either maximize profit or minimize cost, isn't it? That's why this is also called as optimization problem, okay, or inequalities. We said inequality, right? Inequality, okay. Inequality is called optimization or your maximization or minimization problem. Okay, minimization problem. Okay, in we call it, but in practical it is all maximization problem. Okay, so see cost. Okay, if I tell you, okay, okay, the highest value in this world is 100. Let's assume highest value is 100. There is no other value higher than 100. Then what will be the lowest possible value?
Sure.
Minus 100. Okay. Okay. So, your maximization problem, and if you multiply with minus, it becomes minimization problem. Right? What is greater than, if you multiply with minus, becomes less than. Okay. For example, if I tell you here, 10 is greater than 5. Okay. Now, if I multiply both the sides with minus 1, what happens? It becomes minus 10, correct? And it becomes minus 5. What happens to the sign? Will it be greater than? No. Is
Less
minus
than.
10 greater than? Yes.
No.
Minus 10 is less than minus 5.
Yes. Yes.
Okay. So when you multiply something with minus, whole equation when you minus, it becomes, sign will change. Now, it did not impact here because here it is equal to. So equal to will remain equal to. Minus 5 equal to 5 is same as minus 5 equal to minus 5.
Yes.
Okay. So if you multiply both the side with minus 1, it is not going to have any impact on the equality. But in equality, it does. Okay. What is greater than will become less than. Okay. When you multiply both sides with minus 1. So what is max? If I tell you this is maximization problem, convert into minimization problem. So I'll say, okay, let me multiply with minus 1. It becomes minimization problem. Okay. So this is the theory behind it, but we'll see how it is done. Okay. So objective is either to maximize profit or minimize cost. Okay. Now see, if we had, okay, possibilities, right? If we had possibilities, we would make, lots of money, right? Okay. Every business gives profit. Is it correct?
It should go profit.
Right? Not every business. Otherwise, everybody would do business only, right?
Yes. Yes.
Okay. Why it is not possible?
Mm.
Okay. Now, even if business gives profit, then why do we have small business, large business, big business? Everybody should become a big business, right?
Yes.
Okay. You have more people, you have more, because anyway it's going to give you profit. Okay. No, because we have to operate under constraint. Business has to operate under constraints. Okay, so in optimization problem, you have an objective. Okay, this is to maximize profit. Okay, let's talk about maximization first, and then same concept you can apply for minimization. So you want to maximize profit. No business can operate on loss, isn't it? Maximize profit. But okay, you want to increase the profit, but there are some constraints. Every business has constraints, right? Now, if you talk about this part itself, let's say laptop gives you profit of, each laptop gives you profit of, let's say, 1,000 rupees, and each desktop gives you a profit of, let's say, 600 rupees, right? Okay. Now, you can make 1 crore laptops and 1 crore desktops, isn't it? But can you make 1 crore laptops and 1 crore desktops?
Mhm.
Why?
Mm.
Because you may not have demand for them, right?
Yes.
Okay. First thing is demand, right? There may not be that much demand. Okay. Then it could be that, your parts are not available,
Mm.
right? Maybe manpower is not
Manpower.
available, right? So there are a lot of constraints under which you have to operate your business, right? Business does not have unconstrained things. So demand could be that, based on what your sales team is able to project or can sell, you can sell maximum of. Doesn't mean that you will sell. They say, oh, maximum you can sell only for 500 laptops and 600 desktops. You can sell
Mm.
maximum of 500 laptops and 500 desktops, right? Now that's the demand for your product. Now parts could be that parts, okay, you need let's say memory,
Right.
okay. So now memory cards are available, only 5,000 cards are available total, okay. You will have suppliers, right? Supplier will say we can only give you 5,000 cards, okay.
Mm.
Manpower, you have, you can only have machines, let's say manpower, okay, you can calculate in terms of minutes or hours. Let's say you have only 25,000 minutes available in overall, right? So these are the maximum thing, okay. Demand is 5,500 and 600, but okay, if your cards does not allow you to make 500 laptops, cards does not allow you to make 600 desktops, supplier says no, there's a, market is very tight and because of ban and things like that, okay, I cannot give you more than that. So even though demand is there, but you cannot make 500 laptops, right?
Mm.
Even if demand, you have 500, I mean you have raw material to make 500 laptops, but you may not have manpower available, okay. You need to, so see, uh, we cannot hire and fire people every day, isn't it? Or today I need 20 people, let me hire 20 people today, because hiring also takes about a month, right? You cannot say, okay, 20,000 people come here today, right? And tomorrow you cannot say, okay, I need only 5 people, so 15 people you go today, right? Hiring and firing both is time consuming, right? You have to give money if you have to fire. Hiring also you have to go through the process, right? So it's not that immediately, you get people and so you cannot increase or decrease manpower or number of minutes that easily. So your business has to operate within these conditions, and within these conditions, what is my best profit? What is the maximum possible profit that I can make? So it's not just one condition, it's not just demand, okay, 500 into 1,000 and 600 into 600. Okay, that would have been the best thing possible. But do you have raw material to make that many things? Okay, you might have raw material. Do you have manpower to make that many laptops and computers? So we have to calculate, and based on all the possible values, we need to get that answer. Okay, this is called optimization. There's a separate branch of mathematics called optimization, which is based on this concept. Now we are doing just one concept of products. It could be like, you have a, you might have, if you take it to the second level, right? You will have your factories in some corner, right? You might have 2 factories servicing all over India. You might have 5 distribution centers, but you have to send it to each retail store, right? Let's say you make toothpaste. Okay, you have to send it to all the retail stores all across India. How much from which factory should you make? That is also an optimization, right? Which factory, okay? There we talk about reducing the cost, okay? Minimum cost, okay? That because see, you can supply from Hyderabad to all over the India, but the cost would be higher, isn't it? Instead, you start a new factory in North, okay? So that factory will serve North, okay? So your cost goes down. But that's not the only thing. Okay, labor. If labor is expensive there, you have to calculate all those things, right? What is the labor cost? What is the cost of raw material availability, right? Raw material, let's say you're ordering from China, and it comes through
Custom.
Visakhapatnam, let's say. Customs you can set up everywhere, but the port ship, right? The port ship will come to Visakhapatnam. Now from Visakhapatnam again, you have to transfer the raw material to Delhi, or let's say Gurgaon, let's say if you're setting up a factory there, right? So all those costs you have to take into account. Then you say taking all these things into account, we need to have 3 factories or 5 distribution centers or 8 distribution centers, and these are the areas where we need to set up distribution centers, right? So that is again an optimization problem, where you're trying to optimize the cost. When it's optimized, it will be either increasing or reducing, maximize profit or minimize cost. Okay, that could be one problem. You talk about retail stores. When you look at retail stores, number of people operating at the POS, your point of sale, how many counters should they open, right? Bank, how many counters should they have? When you go into a bank, you'll have only one. Some banks will have only one counter, some will have 3 counters, right? So they also have to calculate the cost, isn't it? It would have been nice to have 20 counters, isn't it? Every state is to have 20 counters so that nobody will have to stand in the queue. But they have to pay salaries to the 20 people, isn't it? So what is the best possible number of counters that it should keep it open so that customers are also not angry, and you are also, now if you go to retail store and if you see that the 50 people are standing in front of you, will you buy the product there? No, you will leave it and come out, right? Maybe if
Yes.
4 or 5 is fine. You can, 4 or 5 people in front of you is okay, but not 30 people, 40 people, right? So business also has to see what is the peak hour, what is the non-peak hour, right? Okay, what is the maximum number of people, okay? And based on that, they will decide whether to increase the people in the store or not, because that's the cost, right? So cost versus customer satisfaction, right? So that's called queuing problem. Okay, you have to say that, okay, how many queues you need to make or how many counters you need to open so that the process is more efficient, you don't lose money, and also customers are not unhappy. Okay, so all these things are part of optimizations. We also call it operation research, we also call it optimization problem, and this is one type of our data science. Okay, we are also here predicting, okay, what
Mm.
will be my profit or what will be my cost. Okay, so this doesn't fall under machine learning as such, but this is also one important aspect of this. So we'll stop here, and tomorrow we will look at how to solve such problems using Scipy.